Hi everyone, I'm Xiaqing and I'm happy to be here with you today. This is the third episode in our IoT and ESP32 video series. In today's episode, we'll explore ESP-NOW technology in depth and see how it enables efficient wireless communication among multiple devices. We'll also be using DFRobot's Beetle development board to showcase ESP-NOW in action with a practical IoT project, a motion-activated button. So let's dive into the power of ESP-NOW. ESP-NOW is a connectionless Wi-Fi protocol by Expressive Systems. It's similar to other low-power 2.4 GHz wireless protocols. Devices must be paired before they can communicate. Once paired, ESP-NOW provides secure connections. No handshaking needed for point-to-point links. The connection remains stable if a board loses power or resets. Upon restarting, it auto-connects and resumes communication. ESP-NOW, ideal for multi-device, low-power, low-latency transfer. Unlike traditional Wi-Fi, ESP-NOW needs no router or access point. MAC addresses used for device communication. Each device has a unique MAC address. It simplifies the pairing process, enabling direct device-to-device communication, making it ideal for IoT projects, especially for real-time fast response scenarios. Let's dive into the details. ESP-NOW offers a simple, efficient wireless communication solution. It's particularly useful when full Wi-Fi isn't needed, such as in smart home sensor networks or game controllers. ESP-NOW enables stable, faster communication in these scenarios. How does ESP-NOW work between ESP32 devices? We'll demonstrate this in our upcoming project build. Now let's check out today's development board. DFRobot's Beetle ESP32C3. It supports ESP-NOW communication with low power consumption and compact size. Perfect for our motion button project. Despite being only coin-sized, the Beetle ESP32C3 packs an impressive 13 ports. The board also features integrated lithium battery charging manager, allowing direct battery connection without extra modules. As for the Beetle ESP32C3's expansion board, it offers additional ports while maintaining a compact size. This simplifies soldering for your projects. Additionally, the board's GDI display interface eliminates the hassle of screen wiring. The Beetle ESP32C3 supports both Wi-Fi and Bluetooth 5 for dual-mode communication, and comes with comprehensive documentation. With this documentation, we can easily integrate the board's wireless capabilities into our IoT projects. The DFRobot's Beetle series is renowned for its compact yet powerful design. Ideal for space-constrained projects, both in terms of performance and flexibility. It's sure to meet all your project requirements. Before we begin, let's gather a few materials. Besides the DFRobot Beetle ESP32C3 board, you need a large push button, a small LED strip using the WS2812 protocol, a piezo buzzer for sound, and a lithium battery. And of course, you'll need some wires, USB accessories for device connection and debugging. Oh, don't forget, this is an ESP-NOW project, so we'll need to add a display to the main control unit. The display will show our function menu, and we'll use buttons for selection. Besides the board and basic components, You'll need soldering tools, screwdrivers, pliers, and similar. Once you've got all these ready, now let's move on to assembling our hardware. Here's a connection diagram to guide you through the process. Follow this diagram to connect all the components. Thanks to DFRobot's modular gravity interface design, connecting the modules to the main controller is a breeze. As shown in the diagram, the buzzer should be connected to interface number 6. The button wire goes to interface number 5. For the WS2812 LED connected to interface number 0. Once you've done all that, your main control unit is ready to go. We need to add a display. We'll be using an I2C display for this project. We'll connect it to the I2C interface on our board. Next up, let's see how to install the LED strip. Now solder the WS2812 LED strip, following the GND, VCC, and signal pin order. Lastly, we'll solder the battery. Connect the battery to its positive and negative terminals. While working on this, be careful to follow the correct connection order for each component. Avoid reverse connections, which can damage the components. When soldering, make sure each connection is secure and available. Proper soldering enhances circuit stability and extends the project's lifespan. With that, we finish connecting the hardware. Now let's look at the encoder we've chosen. We'll prepare it for our project. If you're doing this on your own, you don't need to use the same encoder as ours. Any plastic box of the right size will do just fine. Next, we'll place and secure all our modules inside the box. If needed, we can use a hot glue gun for extra security. This ensures everything stays firmly in place, preventing any mysterious glitches during use or play. Okay, now let's close up our encoder. Let's secure all the screws, and with that, we've finished assembling the hardware. Now that the hardware is ready, let's move on to programming. We'll use Arduino IDE to write and upload our code. If you prefer a different IDE, feel free to use what you're comfortable with. Let's start by selecting an ESP-NOW sample sketch from Arduino. Let's take a look. So how powerful is ESP-NOW? We'll see once we upload and run the code. The transmission delay is only 2 to 4 milliseconds. The one-way transmission delay is about 2 milliseconds or 1/500th of a second. That's absolutely incredible, isn't it? I'd say that's practically real-time performance. Now that we've confirmed all devices can communicate properly, let's move on to implementing the next feature. For better understanding, we've created a mind map to outline the program structure for reference. Now let me quickly walk you through the rules of our game design. In our current program, we've set up 3 different modes. Short press to select, long press for 3 seconds to confirm. To switch modes at any time, long press to access the menu. Mode 1 is Whack-A-Mole. In this mode, a red light randomly appears on one of the 4 buttons. Press it as quickly as possible to score. It's just like Whack-A-Mole, right? Mode 2 is Relay. In this mode, each button press turns the press button green. The next button then lights up in a different color. So you need to press this button in sequence. This activates our relay mode. Mode 3 is the hot potato game. In this mode, the 4 buttons light up low in sequence. Press the main button with the screen, and the button lit blue at that moment becomes it. Now let's examine the full motion button project. How does it actually work? In this setup, button states are synced across all devices using ESP-NOW. LEDs and buzzer respond to button states accordingly. Let's also check out our project offers a variety of exciting game modes. For instance, this motion button can be utilized for multiplayer competitions or team-based challenges. This showcases the project in real-world settings, revealing its potential and interactive modes. Our motion button project goes beyond simple gaming applications. It can be adapted to various other domains, such as a controller for smart homes or IoT devices. The possibilities are endless. We encourage you to unleash your creativity and explore more possibilities with ESP-NOW and DFRobot boards. Whether you're enhancing existing projects or creating innovative applications, these technologies open up a world of endless creative possibilities for you. We hope this motion button project inspires you. Feel free to use this tech in your own projects as well. If you have any questions or want to share your projects, feel free to comment below. We're happy to help and excited to see your creations. Links to the DFRobot community and resources are below. Join our community to share and learn from project experiences. That's all for today. Thanks for tuning in to this video. I hope you found it informative and inspiring. Don't forget to subscribe for more cool projects and tutorials. Next up, we'll be discussing ESP32 edge computing applications using TinyML AI projects. Catch you in the next one.